Alright everyone, so far we have seen that what is machine learning, what are different types of machine learning, and what are the subtypes involved in each type of machine learning. And then we have also seen that what are the two basic modes or mechanisms through which we can train our algorithm, right? So we can train our algorithm in an online mode, and we can also train our algorithm in an offline mode. So we have also seen that there are some advantages and disadvantages attached to the offline mode, and we can also see that there are also some challenges or disadvantages attached to the online mode as well. So far we can see that we can have an intuition that the online mode is way better than the offline mode. Why? Because in offline mode, we basically need to put the whole data set to the system at once, and the number one problem which arises is that if the data set size is high, then that training can be time intensive and resource intensive. So time intensive means that it will consume a lot of time to train on that large data set, and resource intensive means that it will require a number of resources in terms of memory as well as processing to train on that data set. So this is the one problem. Another problem is that once we have some new data or new samples in our data set, then we need to do the whole training thing again, right? So this training needs to be performed again and again every time the new data or new sample comes in. So that is the second major drawback of offline learning. But we can see that in online learning we are basically providing our new data along with the old data, right? So our system is basically in the execution mode, and in execution mode it is capable to handle new data as well. But there are also some challenges and disadvantages attached to online learning. So it can happen that the performance of the system may decline gradually, right? And there can be a number of situations in which the performance of the system can be declined. So the number one problem is that if we have some bad data and that bad data is fed into the system, then the performance can decline, right? And that bad data can come from, for example, if you have a number of sensors in your application, and those sensors are basically sensing some data and providing it to the system, and if some sensors basically malfunctions, or they are not sensing the environment, but they are providing some garbage or maybe missing data to the system, right? So in that case we will see that this bad data will basically decline or drop the performance of the overall system, right? And it can also happen that sometimes maybe there is a spammer, or maybe there is an attacker which is trying to decline the performance of your system. And in that case, if some bad data generates and you provide that bad data incrementally to your system during execution and learning, then the performance of the system can overall be degraded. So for that, so you can see that this is a very big and major challenge in online learning, and in that you need to closely monitor the system, right? So what you can do is you can turn off the learning if there is a performance drop, or monitor the input data and remove anomalies, right? So these are the two precautionary measures which you can perform in order to protect your system, or in order to improve its performance. So once you what you can do is you can continuously monitor the system, and if you see that there is a performance drop, then you can stop it, or what you can do is you can basically try to detect anomalies present in the data. You can remove it, and then you can provide it to the system, and in this way your system will not be damaged during the online learning mode, right? But there are some advantages and disadvantages attached to both of these domains, and we need to select very intelligently depending upon the application and based on the data which we have. We need to select that either we need to adopt the online mode or the offline mode, right? So now the third thing which we need to cover in our first introductory session is basically the how our model or how our system is being generalized, right? So we will see there are two ways or two methods. One is instance based and one is the model based method, right? So in machine learning we can have either instance based learning or we can have model based learning. Most machine learning tasks are about making predictions, right? So most of the time what we want is we want our algorithm to train on some data and give us predictions on the unseen data. So having a good performance in training data is good. So most of the time the data on which you are training your system, your model can give good performance on that because it is being trained on that data, right? So that is good. But our ultimate or true goal is to have good performance by the model on the new or unseen data or instances, right? So what we want is we want a system that can give good performance on new instances as well. So that is my ultimate or my end goal. System needs to be able to generalize to examples it has never seen before, right? So generalization here means that I want my system to generalize to new examples, to unseen data, and I want it to give me good performance on the data which the algorithm has not seen before. And if my system can give me good results on unseen data, then I can say that my system is generalizing well on the unknown instances as well. So the first category is instance based learning. So in instance based learning, I have a number of training instances, right? And those training instances can have multiple instances with different attributes, properties. And my goal is that if I have a new instance here, then I basically want to associate this new instance to either of the two categories present in the training data set, right? For example, if this is my whole training data set and it has two different categories, it belongs to two different groups, then in instance based learning my target is to assign this new instance to either of these two classes, right? So it is the most trivial form of learning, and we can say that the system is basically learning by heart. The system learns the example by heart and then it tries to generalize to the new cases or the unseen data using a similarity measure, right? So we have different types of similarity measures available, which we use in machine learning in different algorithms, and I will explain these different similarity measures later on in when we will talk about different algorithms. But for the time being, just keep in mind that in order to assign an unknown instance to any known class, we basically use a similarity measure, and by using that similarity measure our system generalizes to new instances. For example, if we again talk about our spam filtering examples, then we can say that they are identical to known spam emails, right? Known spam emails means the emails that are marked spam by the users. So like supervised learning. Also the emails which are similar to known spam emails, right? So it will require a similarity measure or a measure of similarity between the two emails, right? So we will calculating the similarity measure between two emails. A basic similarity measures between two emails can be a count of number of words they have in common, right? So we can have some statistical similarity measure as well, or if the problem is simple, then our similarity measure can also be simple. For example, in this case we can only count the number of words that are present in both the emails, and on the basis of that we can assign it to the instance. So this was the instance based learning.